This is a spec for the module on range of a function. Range of a function. And in this module, we're just going to give the students a bunch of interesting functions, and they have to find the range. So for example, one of them would be f of x. F of x, or you could even say find the range of, and then we could write f of x is equal to, well, a simple one would be, maybe we could say, put some number up in front here. So 3x squared plus some other random number. So let's say, but it have to be reasonable numbers. So let's say 3x squared, let's make it a negative number, minus 2. And so if the student clicks hint the first time, you could say that 3x squared, or we could say the 3x squared term will always be positive, or the 3x squared term, instead of positive, I should say, will always be non-negative. Will always be non-negative. And even in parentheses, if we want, we could write greater than or equal to 0. And then you could say, so no matter what x you choose, f of x will always be greater than negative 2, which is the leftover term. So the domain, or the range of f of x is all real numbers, I should say greater than or equal to, all real numbers greater than or equal to 2. And I'll leave it up to you. Maybe half of the time we'll want to graph the function, half of the time we won't, because normally when you just see the graph, it's easier to just figure out the range, all of the values that f of x could take on. When you don't have the graph, it sometimes becomes a little less intuitive. So half the time we could draw a graph, half the time we won't. In this case, if we did draw a graph, I'm going to draw it small here, but we'd want the graph paper to be bigger, along the same size as we have in other things, maybe about that big. But if you graphed 3x squared minus 2, it's going to look something like that. And we'll see that very clearly that it only takes on values greater than or equal to negative 2. So that could be one type of problem there. We'd want appropriate choices for the range. And you can look at the domain function. You don't have to have as rigorous notation for it. So it could be, one of the choices, all real numbers greater than or equal to negative 2. That would be the right choice. You could write other things, all real numbers. You could say empty set, whatever you want. You could put a bunch of different choices here. Now, the main, I guess, difficulty in writing this module is to think of all of the different functions that might be interesting that would actually challenge people's understanding of range. You might want to just throw in some give-me's there, some really easy functions, but that maybe the range is all real numbers. But you might also want to have more interesting functions like this. Maybe you have, let me find, maybe I should capitalize the F. Find the range of, and we could have, and you could even, just to change things up, it doesn't always have to be f of x. It could be a g of x or an h of x or whatever you want. G of x is equal to, let's do some random number here, some reasonable random number. So let's say it is 3x times x. Let's say some other reasonable number. So x, maybe we'll say x plus 3. No, I don't want to do a 3 again. Say x plus 2, or all of that over x plus 2. And this could have been minus 2 or whatever. So it could be any number, between negative 10 and 10, or however you want to do it. And if you graph this, remember to draw a hole here. Because if someone clicks hint the first time, you could say this expression, or you could say g of x simplifies to g of x is equal to 3x when, and even in parentheses we could say, the x plus 2's cancel out. You could write it however you think is most appropriate. Cancel out when x does not equal, when x is not equal -2. And then the next hint is g of x is undefined when x is equal to -2. And so then the last hint, so g of x can never equal 3 times -2, which is equal to -6. And you might want to color code it so that this 3, so that people see this 3 is the same as that 3 there. That, look, this is essentially what you're getting to, and you can never get to the point when x is equal to -2. And this one might be an interesting one to graph, or maybe show the graph later on. It's up to you. Sometimes you might want to show the graph initially. Maybe later we just have the graph paper, but we graph it once someone clicks on the hints. And obviously the graph here will look something like this, where, and you'd want to draw the hole in the graph. So it looks just like 3x. The graph looks just like 3x, which is a pretty high slope. So intercept is at 0. So it looks just like 3x, but it has a hole at x is equal to -2, y is equal to -6. So it has a hole right around there. So it'll never get to that value right there. So that's another interesting function where it would be, so the answer to this would be all real numbers except for -6. All reals except for -6. Another interesting choice would be all reals except for -2. That would kind of test whether they're getting confused with the domain and the range. And in general, when we put the incorrect choices, putting some of the correct answer for the domain would be good, because someone might be tempted to figure out the domain and not the range here. And then other interesting functions we can put here. Other interesting functions that I can think of. I mean, you can always have square root functions. So you have something like h of x is equal to 4 times the square root of x, 4 times the square root of x plus 3. Once again, this thing is always going to be positive. So the value is always going to be greater than or equal to 3. Or in fact, I shouldn't say positive. I should be very careful. It should always be non-negative. It could take on 0 when x is 0. So this whole expression is always going to be greater than or equal to 3. Might want to graph it. Other interesting function definitions are the ones where you have kind of these more complex definitions. So g of x is equal to, I don't know, maybe it's equal to 1 when x is less than 2, and it is equal to I don't know, -1 when x is greater than or equal to 2. So here, g of x can only take on two values. The domain here would be the set, or here the range for this one would be literally the set 1 and -1. Or we could say the range is the set that contains only 1 and -1. However you want to express it, you could do things like f of x. I just wrote I mean, you want to do it in black, but f of x is equal to, and it'd be very similar to this. It'd be very similar to this. Pick some number, 7 times the absolute value of x over x. So if x is 0, it's undefined. So we can never equal 0. So never equal 0. If x is positive, then this just becomes +1. So you can have a +7 as a value. If x is negative, this turns into a -1. So you could have a -7 as a value. So the two potential values, the range here is the set of just 7 or -7. So be creative, put a bunch of interesting things. You could have very simple functions, like just y is equal to x, where the range is all real numbers.